Good afternoon, good evening, all our viewers from whichever country you're watching this video from. Today, I'm going to take another new topic, and this topic, you have it both in mathematics and you also have it in further math. The topic of this video, for this particular video, is sword. Sword. Most of us, we do hear of sword and we have issues as regards how to solve it. I will take sword gradually, starting from the rules of sword. So please kindly follow me as I do that. The first sword law is this, which is when you are talking about sword, that's having a form of in square roots, anything having root of a variable, a number that you cannot actually get. You know, there are some numbers we can't get their sword. So that's where you have sword. Now, root of A times root of B. Anytime they give you what? Root of AB. And vice versa. When they give you root of AB, you can simplify it as what? Root of what? A times what? Root of B. Let's see example. We have root 28. How can you solve it? Then we think of what are the two things. You just think of a number that you can multiply that will give you this, your 28. For instance, we know that 1 times 28 is 28. 2 times 14 is 28. Also, we have 7 times 4 is 28. So I can decide to use either 1 and 28. But if I use 1 and 28, I'm still having this question mark. So if I try 2 and 14, 2 and 14 can actually work. Then you can have that. But 14 is not a perfect square. So when you are simplifying, try to look for a prime number and also a perfect square so that you can reduce it, because you need this for reduction. Now I will turn this to root of 7 times what? 4. 7 is the prime number and 4 is the perfect square, which I will simplify as root of 7 times root of 4. On the long run, this will give me root of 7. I can't solve further. This is the last form. But I know that root of 4, the square root of 4 is 2. That's times 2. This will give us 2 root 7. This is simplifying this one in this one. But according to the rule, anytime you have this, it is always equals to root of what? A smaller number by like root of the multiples, or what I call the product, that will give you this your 28. So that's how to do that. Then the next one is the division law, where you have this root of A divided by root of B equals to root of A all over what? B. This is the same thing as this, or I can still write it as root of A divided by root of B. So when you have this, it's the same thing as this, and it's the same thing as this. Let's see example. You have roots of let's say 36 divided by roots of 9. I'm just saying this. So this is the same thing as saying root of 36 divided by 9. And which is, 36 divided by 9 will give you 4. This is going to be still the same thing as saying root 36 divided by root 9. Root 36 will give us 6. Root 9 is equal to what? 3. And 6 divided by 3 will give you what? 2. Also, if you do it from here, 36 divided by 9 will give you 4. Root of 4 is also what? 2. So whichever way you do it, you still have the same answer. So that's for multiplication law. You have your division law. Now let's go to that of square root. Square root, when you have this, n root of AB, it simply means when you have n root of AB, you can simplify it as n root of A, then times n root of B. Or when you have something like this, when you have the same power, so you can have something like this. Let's say example. If I have cube roots of 6 multiplied by cube roots of 4. If you have a question like that, the final answer can be written as cube root of 6 times 4, which is what? Cube root of 24. That's what you are going to have when you solve that. And let's go to another one. Also, when you have n truth, this B, this is C. Let's go to D. When you have the n truth of A all over B, which is the same thing as n truth of A divided by n truth of B. Example. Let's say I have the square roots, or let's say, okay, let me use cube roots of 5 divided by cube roots of, let me even say cube root of 8 divided by cube root of 27. This will be the same thing as saying find the cube roots of, that's 8 all over 27, which will give you 2 over 3. Or better still, you find the cube root of 8. Cube root of 8 is going to give you 2. Cube root of 27 is going to be 3. So that's how you have your answer. Then you have your answer that way. Now, having known this about sword, the next thing is how you undo addition and subtraction of sword. So that will take us to our next topic, which I call addition and subtraction or swords. Let's see examples. Add the following. We have A root 4 plus root 8 plus root 9 minus root, or let's change this root 9, let's put root 27 minus root 3 plus minus root 2. Let's say you have that. Let's see the solution. If you have a question like this, all you need to do is to check whether you can first simplify or bring down the roots to a smaller form. Like now, root 4. Root 4 can be changed to, I have root 4. Root 4 can be changed to 2. Root 8 is the same thing as root of 4 times 2. Which will give you, root of 4 is 2, that's 2 root 2. Root 27, I can break it down as root of 27 can be written as 3 times 9, that's 3 times 9, which is, I know 9 is a perfect square, 3 is a prime number, this will give me 3 root 3, because root of 9 is 3 and root of 3 still remains the same. Then, let's check, root 3 is in its final form, root 2 is in the final form. Then I can change the question. Now the question comes to, it will now be 2 because root 4 is 2, plus root of 8, that's 2 root 2, plus root of 27, that's 3 root 3, then minus 3 root 3 minus what? Root 2. Then here comes where you put what we call your BODMAS. You introduce your BODMAS. Then you have 2 plus 2 root 2. We bring the like term, that's minus root 2, plus 3 root 3, then minus root 3. Then I noticed that most students actually have issues with something like this. It's actually simple. It's just like you doing normal subtraction and addition of whole numbers. Like when you say 2 plus 1, that's 3, or you say 2 minus 1, which is 1. So all you need to do is to find the coefficient of whatever number that is after the surd. Like now, the coefficient of surd 2 here is 2. Coefficient of this surd 2 is also what? 1. The invisible one is here. For this one, surd 3 is what? 3. For this one is invisible one. So this more or less like saying 2 minus 1. Because we both have root 2. Or when they ask you like 2x minus x. You know, that's more or less saying that 2x minus x will give you x. So 2 minus 1 will give us ordinary 1. So I have 2 plus 1 root 2. That's what? Root 2. Also here we have 3 minus, the coefficient here is invisible 1. 3 minus 1 will give us 2. That's plus 2 root what? Root 3. And that will be your final answer when you solve it. I believe you are getting along. Let's still move on. Let's see another one that we call rationalization. Rationalization of surd. Now, talking of rationalization, we have rationalization of surds. Let's see example. Rationalize the following. A, let's say you have 1 over root 2. B, let's say you have 3 over root 3. C, let's say we have 1 over root 2 minus 1. And D, let's say we have 1 all over 2 root 2 plus root 3. Well, I will do A and B now, and first take a subtopic before doing this second one, and before doing C and D. Let's see solution to A and B. When you talk about rationalization, it's simply talking about a way you balance. Like now, just like in fraction, we have different types of fraction, proper fraction, improper fraction, we have mixed fraction. In surd, we have something that we call proper surd. A proper surd is when you have a surd on top of an whole number. But when you have an whole number on top of a surd, then it's not what? Proper. So when you say rationalize, that means they want you to turn it to a proper surd. Then how do you do that? All you need to do is to multiply by the denominator of that surd. So we have A, 1 over what? Root of 2. Then you multiply both the denominator and the numerator by the denominator that you are having here, which is what? Root 2. Then you say over what? Root 2. So this will give us 1 times root 2 will give you root 2. Root 2 times root 2, that will give you all over what? Root 4, which is equal to root 2. Root 4, you know root of 4 is what? That's 2. So root 2 over 2, that is a rationalized form or a proper form of sort. So this is rationalized. Then let's go to B. You have 3 all over root of 3. How will you rationalize this? Don't forget the logic. You must multiply by the what? The denominator that we have, and you multiply both numerator. It's just like saying you are multiplying by 1. You know, this divided by this will give you 1. Root 2 divided by root 2 is 1. And 1 multiplied by any number is still the same number. So we have this multiplied by root 3 all over root 3, which will be equals to 3 times root 3, that will give me 3 root 3. All over root 3 times root 3, that will give you root 9, which is equal to 3 root 3. All over root 9 will give you 3, because root of 9 is 3. Then look at it. I can leave my answer this way, but it's not yet in its best form. So it will be in best form. 3 can cancel 3, which will give you final answer of what? Root 3. That's how to solve that. Now for this C, you need to know a topic, a subtopic. This is what I call conjugate. Conjugate pairs. Example. Find the conjugate of the following. A, I will use the things that we have here, root 2 minus 1, and B, we have 2 root 2 plus root 3. Now, what's the meaning of conjugate? Because I know that's your question. Conjugate simply means what you can multiply with this thing that will give you what we call a perfect square. What you will multiply with this. You know, there's something we call difference of 2 squares. And difference of 2 squares simply, okay, that will give you difference of 2 squares. Like now, difference of 2 squares states that a squared minus b squared must give you a minus b into bracket a plus b. That's what this, your difference of 2 squares, is talking about. So when you talk about conjugates, it's talking about the opposite of whatever you are given. So the conjugate of a plus b is what? A minus, let's see, like now, let's now put roots there. If we have root of a plus root of b, sorry, minus root of b, then you have this one all squared, this one all squared. This is meant to be equals to root of a, that's going to be what? Root a minus root b, then open brackets root a plus root b. So if you multiply these two together, you are going to have this. If you have this, that's the same thing as root a all squared will give you a, then root b all squared will give you a b. That means a minus b is always equals to your root of a minus root of b into brackets root of a plus root of b. So the conjugate we are talking about of this particular form is going to be your what? A root a plus root b. Applying that to b, a, we have root 2 minus 1. The conjugate of root 2 minus 1. You know, if one is minus, the other one will be plus, because this is what we call conjugate. The conjugate of root a. Or let me first write it. Conjugate, if you have conjugate of root of conjugate of root a plus b, root b is root a minus root b. So let's now use that one. So that means a, the conjugate of root 2 minus 1 will just be root 2 plus 1. That's the answer. Then b, the conjugate of root 2 plus root 3. I know you want to answer this. Yes, that's it. That's the correct answer. That will give you conjugate of root 2 plus root 3. All you need to change is this plus, you change it to minus. That's 2 root 2 minus root 3. That's how to find conjugate. Now back to our question when you ask to rationalize this. rationalize A 1 all over root 2 minus 1, then B 1 all over 2 root 3 plus 2 root 2 rather 2 root 2 plus root 3. When you have that, so how will you do that? Solution, you now say 1 all over root 2 minus 1, then you multiply by the conjugate. You know when we are dealing with this one, you multiply by the denominator, what you have as the denominator. But here, we are having the denominator as root 2 minus 1. So you multiply it by what? The conjugate of root 2 minus 1, which we have gotten, and that's what? Root 2 plus 1. So you multiply both numerator and denominator by root 2 plus 1, then times root 2 plus 1. So you do it that way. So let's see what this will give us. 1 times root 2, that's root 2. 1 times 1, that's plus 1. That's what you have there. Then all over root 2 times, you use this one, the first one to multiply the whole of this, and take the second one to multiply root 2 times, okay, maybe I should write it as root 2 into bracket root 2 plus 1, then minus 1 into bracket root 2 plus 1. So by the time you do that, that will give you root 2 plus 1 all over root 2 times root 2, that's 2. That's root 4, which will give you 2. Root 2 times 1, that's plus 2 plus root 2. Then minus 1 times root, that's minus root 2. Then minus 1 times 1, that's minus what? 1. On the long run, that means your answer will be root 2 plus 1 all over this. We cancel this, which is just be 2 minus 1, which will give us 2 minus 1 is 1. The final answer is root 2 plus 1. You know what I explained here, that this the final answer you'll be having, because when you multiply the numbers, two sorts by a sort by its conjugate, what you are going to have is A minus B, which is what you have inside the sort minus what you have inside the second sort. So which is, you can see, root 2 and 1. All you need to do is square this one. When you square root 2, you have 2. When you square 1, you have what? 1. 2 minus 1, which is talking about the difference of 2 squares. Do you understand? So that's how we are doing. That's the final answer for rationalizing this. So this is the rationalized form of A. For B, we have 1 all over 2 root 2 plus root 3. You multiply by 2 root 2 minus root 3. Then all over, that's the conjugate of this one, all over 2 root 2 minus root 3. Let's solve it over there and see what the final result will be. So solving that, 1, so let me write it here again. 1 all over 2 root 2 plus root 3. Then you have times 2 root 2 minus root 3 all over 2 root 2 minus root 3. 1 times root 2 root 2 will give you 2 root 2. 1 times minus, that's minus root 3. I'm done with the numerator. Now we are going to the denominator. That will be 2 root 2 into bracket. I will say this first one into bracket, this, and take the second one into bracket. 2 root 2 into bracket, 2 root 2 minus root 3, close bracket. Then we have plus root 3 into bracket, 2 root 2 minus root 3. And don't forget, this is multiplying this 2 root 2 is a conjugate of this. And when you multiply a conjugate by itself, you might not even go through this stress. Root 3 all squared. If you square this one, that's 2 squared times what? Root 2 all squared minus, this will give you root 3 all squared, with root will cancel this, that will be minus 3. So this is 4 times root 2 all squared. 4 times 2 minus 3. And 4 times 2, that's 8 minus 3. That's what you have. You see that we also have this same thing here. Let's see. 2 root 2 times, that's 2 root 2 minus root 3 all over 2 root 2 times 2 root 2. 2 times 2, that's 4. Root 2 times root 2, that's times 2. Then 2 root 2 times root 3, that will give me minus 2. That will be, Don't forget, under the law, root 2 times root 3 will be root 6. 2 times 3, that's what? Root 6. Then I'm done with this one. I'm going to this place. Root 3 times this with that's plus, that's 2. Root 3 times that's also what? Root 6. Then root 3 times root 3, that will give me root 3, that's what? Ordinary 3, that's root 9. Root 3 times root 3 will give us root 9, and root 9 is 3. You will see that this cancels this, which will give us 2 root 2 minus root 3 all over 4 times 2, 8 minus 3. You can see we have what the same thing we are having here. So it's either you square this and put minus in between, irrespective, or you go through this long process, whichever one you understand more, which will give us 2 root 2 minus root 3 all over 5. And you can simplify it as 2 root 2. You can leave your answer like this or say 2 root 2 over 5 minus root 3 over 5. That's all about rationalization, and I've taught you conjugate. The last part I'm going to teach you is this next topic, but let me rub the board while I tell you the next topic. Alright, the next topic is what I call radical equation. Radical equation. This is still undersolved. And how do you solve it? Let's say example. In this case, you can be asked, you can have something like this. Solve for x. You can have something like roots of x plus 1 minus, let's say roots x, you can say is equal to 4. And you should solve this equation. How are you going to go about it? I'm not assuming this is correct, but I will take you through the process of how to solve something like this. So let's see. We have, you have roots, you transfer this one to this other side. Then you have, okay, let me just start the solution after. Solution. You now have root of x plus 1 minus root x equals to 4, which will give me, don't forget the root of this is going on. That's root of x plus 1 equals 4 minus root x. That's how you do the first step. That's the first step. Then the next thing is square both sides. Square both sides. Which means I will have root of x plus 1 all squared equals to 4 minus root x, everything all squared. Please, you should know the difference. The difference between when you have this all squared and when you have each of them all squared. Because so that some of you will not be seeing this as difference of two squares. No, this is all squared. So you should know the difference. That is in 2 places. So now this is going to be root x plus 1 multiplied by root x plus 1, which is equal to root of 4, which is equal to bracket 4 minus root x into bracket 4 minus root x. That's how we go about it. Now, looking at this, root times root, when you use the root to multiply itself, that means you are going to turn this root of x plus 1 in 2 places. They will cancel one another. That means on the long run, this is meant to be root of x plus 1 all squared. This and this, that will be, because x plus 1 is in 2 places, that's all squared, equals to 4 times 4, that's 16. 4 times minus root x, that's minus 4 root x. minus x like this, that's minus 4 root x as well. Now minus is plus root x root x will give you ordinary x. If that's the case, then here, this square, we cancel the square root. You have x plus 1 equals 16 minus 4. You also want 4 naira. I still want to borrow another 4 naira. That's, you are already passing 8 naira. That's minus 8x. You can apply this to your normal daily life activity. This is like a debt. So when your debt is what? Increasing. So you are having a debt of what? 8. That's how I got that debt plus what? X. You have that. So in the long run, I will try to bring like terms together. So we have x plus 1 minus 16 equals minus 8 root x plus x. Let's do gradually. This is x. 1 minus 16 will give us minus 15 equals to minus 8 root x plus x. Then let's bring this x here. That will be x minus 15 equals minus 8 root x. You know, this plus x here. When it comes here, it comes to minus x. That's why we are having as minus x. This x is this one. So an x minus x, we know that is 0. So I have minus 15 equals minus 8 root x. If you have something like this, you can divide both sides by minus 1. And you divide by minus 1, you have 15 equals 8 root x. When you have something like this, you are not yet done. The next thing, you can interchange. It's just like me telling you that Ada equals Shegun. I can reverse it and still write Shegun equals Ade. That's what we call equality. So therefore, I can write this as 8 root x equals 15. At this very point, I don't know what to do. Then the next thing you still do is to square again. So you say square both sides. So that will give us 8 root x all squared equals to 15 all squared. If you square this one, 8 squared will give us 64. Root x all squared, that's times x. When you square root x, you have x. So that means this is 64 times x equals 15 squared will give us 225. This will now be 64x equals 225. On the long run, x will be equals to divide both sides by 64. That's 25 over 64. You can leave your answer like this, or decide to put it in terms of a whole number and a fraction, or you decide to put it in decimal form. This is where I'm going to stop. But before I go, let me give you a classwork for you to attempt. Kindly attempt the following. Attempt this. Number 1 is rationalize. Rationalize the following. A 1 over 3 root 3. B 5 plus x all over root 2. Then number 2. What is the conjugate of 3 root 3 minus 5? Then number 3. Let's say solve for x. Sorry, let me get a equation. Solve for x. Okay, let me write it x. Solve for x. We have root of x plus root of x plus, let's say, plus 5 equals 5. So you can find these are the 3 questions I want you to attempt. You can kindly write your answer for each of the questions. If you're answering 1A, 1B, you write 1A. This is the answer, 1B, this is the answer. Then I will tell you if you are right or not. You comment your answer at the comment section. This is where we will be stopping at King of Mathematics for today. Until the next video, make sure you subscribe, like, comment, and share to your lovely ones wherever they are, whether Nigeria, overseas, or where it may be. Until the next video, bye.